GraphiCAD 2010 has the facilities for creating arrays of geometry. It's pretty straightforward. Let me show you the concept. So the geometry that you want to use for creating the array must be either selected or open. And in this state, the mirror, copy, and rotate uh, functions become active. This is mirror, this rotate, and this translate. And let's say I'm going to mirror this geometry, then I get two options here, tool options. If I do not wish to retain the original geometry, then it'll just mirror it and bring it down, make a mirror copy. No copy. Let me draw a line. You can also use a line as a reference for mirroring. So let's try this geometry again, and this time we will use the copy option, so I can use this line for referencing. This paradigm is available for the other two tools also. Let me just remove this, and let's say we have a geometry here like this, and I want to make an array of the lines. So I come here and say rotate. So once again, there are two options. This is for a single copy without and doesn't retain the original. Just I can choose any axis. I can rotate about its own endpoint, and I say the angle 45 degrees, and it rotates the geometry. But if I use the same thing and I say make a copy, so I can go to the endpoint. Now it asks me, so let's say 60 degrees, and I want 5 copies. So I have the array. The same thing works with translate also. Let's say I have a geometry here and it's selected, and I can use the translate command. Once again, you can translate with or without copy. Let's do it with the copy. So first thing it's asking me is the start point of the translate, so I can use the origin of the circle itself or any point that I want. And then let's say it asks what direction you want to translate. So let's say you want to go horizontal, so you put angle 0. And what is each step? So let's say 40 millimeters, and I want 5 copies. N is 5. So you got the 5 copies. And so it's pretty straightforward to create these arrays. You can also create constraint arrays. Let me explain to you what I mean. This is a little tricky. Let's say if I have a geometry here and I have a line which is tangent to this. So if I select this and let's say ask it to give me a rotate around here by 60 degrees and N5, each of the components retain the constraint. So what you can do, for example, is something little clever. You can, for example, allocate a cell, let's say 10 millimeters, and then let me create a circle and say the radius of this circle is constrained by the value of this cell. And now I will constrain a line to be tangent to this. So now I'll select this, and let's say you can use rotate again, and I want to rotate about the end of this line. Actually I need a, so I rotate about the end of this line. Angle is 60 degrees and 5. Now if I change the value here to, let's say, 5 millimeter, the whole array will update. And actually, this can also be used for back solving the array's properties. For example, sometimes when you're designing flanges and stuff like that, you need a total area or section property of all the bolts going through the flange. So let me calculate the area of one of these. And so the area of the 6 is multiplied by 6. Now I cannot goal seek a cell, so I can put a line here, and the line has a length. Let's say we start with 5 millimeters, and we can say the value of this cell is equal to length of this line. This is a technique. So now let's say I wanted the 6 bolts combined area of 500 millimeter to the power of 2. So I can select this line and say goal seek this value to this value by changing the length of the line. So you will get the answer here on what the radius should be. So this is something that you can use to create constrained arrays and then back solve using the value of a cell which is driven by a line. So essentially the mirror copy and translate tools are very handy when you're defining a system of bolts or flanges, or you want to create a shaft and you want to mirror it over. It's fairly straightforward to use. Thank you.